students, I am Dr. Anu Mudgal. So let us start with the topic. Introduction. Aldehydes and ketones are carbonyl compounds having one CO in which carbon and oxygen are doubly bonded, and the rest of the two valencies of the carbonyl carbon are one is either aryl or alkyl group, and the second one in aldehydes is fixed this hydrogen, whereas in case of this hydrogen is fixed in case of aldehydes, whereas in case of ketones, the both valencies are taken up by either alkyl or aryl group. So in a ketone, the carbonyl is basically embedded by between two different or similar aryl or alkyl groups. Alkyl, then it is aliphatic, and if it is either one of them is aryl, then it will be aromatic. So these are carbonyl compounds, aldehydes and ketones. A little background of them. Aldehydes and ketones are widely available in nature. They occur in plants, they occur in microorganisms, animals and humans. So you see, these aldehydes and ketones are not only important in your chemistry class, your chemistry curriculum, but they are equally important created by nature in your day-to-day life also. So let us see a few examples. They are known for their sweet and sometimes pungent smell. The famous examples are vanillin, extracted from vanilla bean, the cinnamaldehyde, extracted from cinnamon bark, benzaldehyde, that peculiar scent of the almonds. Camphor, you know it very well. It's majorly used in all the worships and things like that. Then we have hormones, progesterone, testosterone, muscone, and some of the pleasant smelling aldehydes and ketone containing molecules are often used in perfume industry. For example, the Himalayan deer, it smells so nice that the compound extracted from that is used as in perfume industry, right? So you see that aldehydes and ketones are an inevitable part of many industries. So let us, although we have already discussed in detail in the nomenclature lecture, let's have a quick recap of aldehydes nomenclature first. So whenever you see a carbonyl compound, you first have to find the longest continuous chain containing the carbonyl group. And in case of aldehydes, you have to number the carbonyl chain in an order that you will place one number for the carbonyl itself, then respectively numbering the parent chain and thus naming the parent alkane. So the suffix E of alkane will be replaced by the suffix Al. So here, for example, we have 1, 2, 3, 4, 5. It is the parent chain is alkane. So for alkane, pentane, you will delete this E, and in spite of that you will write Al. So it will be pentanal. So this H, this R will not be here. In case of aldehydes, this H will be here. So this will be called as pentanal. So here we have a few examples. Methanol, when we have both the hydrogens. Ethanol, when we have one as methyl and one as hydrogen. And we have pentanal. So this was all about aldehyde. Next, ketones are named similarly. You have to look for the carbonyl containing parent chain, but here is a little difference. Okay, so what is the difference that what is the difference that here the carbonyl is embedded between two carbons? So this aryl or alkyl group will be having at least one carbon. One carbon chain will at least be present here. So for carbonyl, the lowest number that could be assigned in ketones will be 2 rather than 1, unlike aldehyde. So suppose if we say that here we have CH3, the methyl group, then it will be numbered 1, 2, 3, 4, 5, 6. So this will be a 6 chain hexane, and you have to keep in notice that the parent chain E will be replaced by the term on here in case of ketone. And you also have to attach a numerical prefix. So here in case this 2 will be prefixing the term hexone. Hexane will be hexone, and you have to tell the placing of the carbonyl group, right? So this is the main point, not going into much details. These are few examples. Propanol, which is basically 2-propanol, this is 2-butanol, 1, then 2, 3 and 4, and this is 2-hexanone. So this was all about ketones. If you still have any queries, we can discuss at the end of this session, right? So now coming to the physical properties, most of the aldehydes except the first member, formaldehyde, which is a gas, all the aldehydes are liquid at room temperature. Then the lower ketones from the series are colorless liquids with pleasant smell. The higher ketones are, unlike the lower ones, solids, right? And the aromatic ketones are totally solids with pleasant smell. So a chart you can make like this for revision at the end of the course or at the just before your exam, so that it's these short notes, charts like these of physical properties, of nomenclature, of chemical properties, of reactions. Okay, for reactions also I will tell you the 5 key points that you can remind for every reaction, and it will be easier for you to memorize. So coming back to the topic, for boiling points, the strong dipole-dipole interaction. This dipole-dipole interaction between two carbonyl groups, CO, is a polar molecule. Why? Oxygen is highly electronegative than the carbon. So it will have a tendency to withdraw the electron density towards itself, which will result in delta positive or partial positive charge over it, and carbon will result in oxygen will have partial negative charge and carbon will have partial positive charge. So this dipole-dipole interaction between the two carbonyl groups will lead to higher boiling points when they are compared to the comparable hydrocarbons. But this dipole-dipole interaction is not very much stronger when compared to the intermolecular hydrogen bonding of comparable mass alcohols. So they will be having, the aldehydes and ketones will be having lesser boiling point than the corresponding alcohols. Now coming to the solubility, the lower members of both series, both here we are talking about the aldehydes and ketones, lower members means up to 3 carbons, right? So up to 3 carbon series are soluble in water due to this weak hydrogen bonding, whereas the higher members are soluble only in the organic solvents because of the non-polar part increase. The R group, which is present in aldehydes, in ketones, that increases in molecular mass and thus the non-polarity. Okay. Next, coming to the chemical properties, both aldehydes and ketones are highly reactive compounds due to the presence of polar carbonyl group. This polar carbonyl group, which renders it partial negative charge over oxygen and partial positive charge over the carbon. Okay. It generates a nucleophilic center over oxygen and partial electrophilic center over the carbon, thus making carbonyl highly reactive. Also, the carbon of carbonyl is sp2 hybridized, which means that the carbon and oxygen both are in the same plane, but the other two valencies, one is below the plane and one is above the plane. So this also makes the planar arrangement of carbonyl moiety also makes it highly reactive. I hope you enjoyed this session also. We'd like to continue in the next. Till then, take care. Thank you.